Hi and welcome to the first class in the Autodesk Bifrost training series. This new software is going to rock the effects world. It's amazingly fast, super detailed. It's built right into Maya. It's better than Naiad, which was the expensive Linux fluid simulations tool that was used on countless feature films and purchased by major VFX studios worldwide. As Maya 2015 comes out next week. This week, we're going to be looking at some of the solutions used to create water in previous versions of Maya, just to tide us through till Bifrost is available on your computer. So we're going to be having a look at Maya Oceans, Maya Fluids, which is this little red simulation here that we're looking at, which is mainly used for gases. This is another Maya Fluids example we're going to be having a look at, which is the Fireball. And all these files are available on the area, which is Autodesk's website. This is an example that we're going to have a look at of regular Maya particles with a simple emitter pouring little droplets of water into a cup. We're just going to have a look at also Maya N particles, which can actually self-collide with each other and be rendered as a cohesive, blobby, liquidy surface. And finally, after we've explored Maya Oceans, Maya Fluids, particles, and N particles, we're going to have a look at a pre-rendered Bifrost simulation. We're not going to be able to change the settings, but I'll just talk to you about how it can actually collide and simulate much better than the other types of simulations. So let's get started with this ocean simulation in Maya. Okay, let's take a look at this Maya Oceans example. So set the scene to dynamics, and then in fluid effects, we're going to load a ocean example. So in the visor, we're going to right click giant storm anim.myascii. And as you can see here, we've got a kind of large geometry floating around in the sea. So if that just had a grayscale shader on it, it wouldn't look too awesome. But what it's actually got is a very complex ocean shader. And when you render it, it creates a really realistic looking ocean type of surface. So although this isn't an actual fluid simulation, the way that Bifrost simulates it, what it's actually doing is it's using a very clever shader to replicate what a large surface of water looks like. So as you can see, there's high crests on the waves, there's foam, there's reflections, there's bump maps, there's mist happening, and there's all kinds of different effects to give it the look of a stormy sea. So this is one of the ways that you can create a sort of watery effect in Maya, and this has been used over the past like 5 to 10 years in movies as a bit of a trick to get the ocean. So as you zoom out there, you can see the ripple waves in the geometry. So in the past, a lot of ocean scenes in movies, like Terminator Salvation, that was done at RSP, and The Perfect Storm, that was done at ILM, the way they did the oceans was through creating geometry that deformed, and then applying kind of foam alpha channels, and then writing scripts to have the foam appear at the crests of the waves, and have the darker shaders appear in the valleys of the waves. And this way, as the animation of the water would run, the textures would appear and disappear in the right place on the wave crests. So that's how they kind of trick you into looking like it's a huge body of water, but it's actually just a paper thin geometry with a colored water foam texture mapped onto the surface. Now, one of the interesting things to notice about these ocean examples here, we're just going to load up another one, which is high seas. So if you right click and then import that into the scene and then close the visor, what we're going to do is I'm going to show you how objects interact with these oceans. So the example I've chosen isn't a pond simulation, it's just a regular shader ocean. And what we're going to do is we're actually going to drop a ball into this ocean, and I'll show you how it doesn't actually interact with the water the way that naturally it would. So this geometry here is actually showing us, it's kind of like a preview of the displacement or the geometry of this ocean shader. So we're just going to increase the resolution a little bit, and this little square is showing us the movement and the geometry of the water waves that are flowing through this procedural animation of the ocean. So if we zoom out and take a render, we can see that there's a huge amount of geometric detail at render time of all the little bumps and crevices of this water. And to model that and set it as blend shapes or some other similar thing would just take so much time. And this is just a great technique for creating huge scale water. The only problem is, what we're going to do here is just create a sphere in the viewport and move it up and position it over the top of this this demonstration square here. That's the ocean sort of preview. You don't need to have it over this specific place, but I'm just showing you as an example. And what we're going to do is I'm going to set 2 keyframes so that we can see the sphere definitely intersects with the water. So you can see there it goes straight through the top into the water. So if this was a like a bowling ball going into the pool, you would expect on the frame that it intersects with the water that there'd be a big splash or at least some foam around the edges of the sphere. But as you can see in this render, the sphere is halfway through the water, and there's absolutely no interaction whatsoever happening between the geometry of the sphere and the geometry of the water. So this is one of the main limitations of this ocean type software, is that if you were going to throw a transformer or one of the robots at a Pacific Rim into this ocean, you'd have to do a separate simulation using particles to get the interaction between the object falling into the water, be that a ship or a creature, and the actual water itself. And then you'd have to sort of blend the three together, blend the ocean, the particles, and the geometry kind of masked out so that you're able to get it working. So with mya218, we can see it's really fast and interactive. It doesn't slow down the viewport when you play back the frames, but it's not really a dynamic simulation where you can crash an aircraft carrier or a jet or drive a ship through this ocean and get like a really spraying interactive effect. Next, we're going to have a look at Maya fluids. So what we're going to do now is just have a look at Maya fluids. So I'm just going to turn on the grid and go up to File, Open Scene, and I'm going to open the orange die, which is off the area Autodesk site. So this cross that's on the viewport is actually a dead viewport image. So I'm just going to go into the hypershade and quickly delete that image plane so that we can get rid of that cross. Once we've closed that, I'm just going to talk to you a little bit about Maya fluids. So one of the confusing things, I guess, is that software like Scanline's water simulation software, Bifrost, and RealFlow are the simulations software that you use for doing water. Maya fluids is actually fluids in terms of pyrotechnic fluids or smoke fluids. So you know when there's a lot of dust in the air and you swing your arm through the kind of through the air and it swirls all the dust coming through shafts of light. That simulation of air and matter passing through air is the way that this mya218 solver works. So how it renders is it, instead of using particles, it actually uses voxels. So a voxel is basically a 3D pixel. So every part of this image that we're looking at is actually a slice through a solid 3D box, which is a voxel box, and it actually measures parts of the simulation in terms of heat and density. And how it renders is there's a ramp on the density, and it will have a cutoff point at a certain setting, and once you set the density to be 0.1 or 2, you can then render the smoke at the densest part of the image and clear air at the last part. So what I'm doing here is just playing slowly through the timeline, and you can see how slow and how detailed this voxel-based air simulation is. So this is mya218, but you just don't use it for water simulations usually. It's usually used for fire, smoke, explosions, and things like that. But as you can see, it's just got awesome effects the way it shadows itself, the detail in the turbulence. When it's in motion, it looks really lifelike and natural. And I've used it on a lot of TV show work that I did at the Post Lounge, and it was just an awesome, natural sort of simulation software. You need a pretty fast GPU and computer to run it. However, I wouldn't suggest using mya218 on really large scale smoke and pyrotechnics unless you had a computer with a lot of RAM and a good multi-core CPU. But it's a great tool for things like explosions, dust trails coming off particle rigid body simulations, things like flares and smoke trails coming off like the Navy SEALs have lit their flare ready for the helicopter to pick them up. It's great for all that kind of stuff because it's just so detailed and so good. The only downside to it is it's just ludicrously slow to update in the viewport. So you don't want to be using it for quick turnaround TV commercial kind of work. So in the actual fluid settings, I've got the fluid field and the fluid emitter selected. This setup has a motion field which helps to pull the fluid through the container, and what that does is it actually avoids the kind of stair-stepping, stuttering effect that you get. All right, now let's take a look at this other fireball scene, which is another mya218 setup, and I'm just going to show you. It's for fireball.mya218. Just going to open that scene. Now, on the bottom of this box, you can see the actual voxel squares, which is the resolution of the scene, and that's set up in the attributes for the mya218. So we can see it's got a resolution of 150, 75, 45, and only the bottom of the fluid container is showing the resolution. So you can change the view setup for that. And that's the frames of the simulation along the bottom there. So I'm just going to play this through and pause the video quickly to give you a bit of simulation so that we're not waiting around. And this is what it looks like after we've played 61 frames of the fluid sim, which took about a minute. So what we can see here is that it's a very highly detailed, illuminated, sort of fiery smoke simulation. Now, if you're going to do this with particles, and sprites or something like that, you just need millions and millions and millions and millions of sprites to simulate this. And they wouldn't necessarily move in a lifelike, fluid way either, because sprites often work best when there's fewer sprites with a better texture on the sprites. So as you see, we can pan around this. It just looks super awesome. This is another area demo scene that you can take a look at. But as you can see, Maya Fluids isn't water simulation. It is, for effects, it is just getting things that are on fire or have heat or density or temperature, and then you're actually putting them in this container. And you can see the top of the container here where the fluid actually runs out of simulation room, and you can see that the fluid is actually intersecting and colliding with the extents of the box. So you can't kind of just run this missile trail all over the place. It'll kind of be, it'll finish at the corners of this fluid container. And the bigger the fluid container is, the lower resolution the simulation that you run will be. So if I was going to make this like a F-22 missile trail, I'd get a lot less detail out of the fluid simulation that I'm running. So what we're going to have a look at now is I'll just show you some of the basic fluid attributes. So in Boundary Drawer, that shows you where you can change the display of the fluid container. So where this box ends is where this Maya fluid ends as well. So I'm going to set it to none so that we can see the smoke trail. I'm just going to play it through a little bit. So as you can see, it's really slow to simulate compared to the awesome speed of Maya N particles and regular particles, just because of the amount of computation and the difficulty of displaying voxels on the GPU. So we're just going to go into some of the settings in here. So down here we've got fluid emission turbulence on the fluid emitter. You can go to wireframe display and show the fluid as particles. Let's just change some settings on this fluid to have a look at what controls we actually have over this simulation. So I'm just going to set the bounding box on so I can see where the ends of the fluid simulation is. The slices per voxel, it's best to leave that at 2. The viewport control, the view control is just to set up how the voxels are displayed, which will make it either higher performance or better quality. And with the actual fluid container selected, if you go down to in their color settings down the bottom, there's actually an output that is shading. And if you go into shading, there's a ramp where you can control the fluid's temperature and density controls. So in here, it's got the incandescent input of black, brown, red, and yellow is mapped into the temperature of the fluid inside that container. So as you push around these sliders on the ramp, you can actually change the look, not only in the viewport but in the render of this fluid, and that's how you actually adjust the look of explosions and other pyro Maya fluids kind of dynamic effects to get the look that that the director wants. Another good idea is you can get reference footage and just use the eyedropper to color pick the right colors so you can match it to the reference footage. Next, we're going to jump into Maya particles. So with the dynamics menu selected on this drop-down list, where I'll just show you a few settings. Now in the particles menu, you've got create emitter, emit from object, and in the fields menu, you can add gravity, turbulence, and all kinds of other fields to affect the particles. So we're just going to create an emitter and play back the animation, and you'll see there's some tiny little grains of sand particles being emitted here. So I'm going to select the particle shape and go down to spheres just so we can see them a bit easier. and I'm going to scale down their radius so that they're a little bit smaller. Now what we're trying to go for here is a kind of hose spraying water out of it. So mya particles are deceptively simple because you can actually map very complex shaders and geometry onto particles in Maya and Houdini through RenderMan and Arnold. So at the high-end film level, simpler and simpler tools like Maya and Houdini particles can be used for more and more complex effects, because at render time, you can actually mesh, motion blur, do subsurface shading. You can do super complex, multi-layered, multi-pass, multi-million particle simulations on particle farms, and it almost makes fluid simulation software like RealFlow and Bifrost kind of pale in comparison to the awesome speed and efficiency of using these simple particle systems. The only problem is that as you can see with this water spray, they're very basic dynamic simulations. So I've just increased the rate, put in a gravity field, increased the rate to a bit higher, and I'm spraying out a kind of long stream of these droplets. But even when that's rendered with a really nice material and motion blur, it still looks pretty basic. So if you open up the scene that I've pre-made for you, which is pour normal Maya particles, that's normal as in regular, not normal direction. So if we select the particle group, what I've set up here is an emitter inside a cup, and it collides with the pouring cup and the glass cup. And what we're going to do is I'm going to play through this animation so you can see how the cup tilts and pours into the other one. And I'll show you that even though these particles are super fast to play back and simulate, there's a bit of a problem when it comes to the particles actually creating a volume. So with Bifrost, when you pour liquids into a container, the liquids actually have pressure exerting outwards from the particles. So they'll actually maintain a volume of their sort of water pressure. But with Maya particles in this default sort of setup that's straight out of the software, you can see that it does an awesome job of pouring water droplets, but the particles don't actually press on each other. There's no internal pressure to the water beads that are pouring into this glass. They all just intersect with each other, and they don't have any kind of inter-particle collisions. And what that basically means is that no matter how many billions of particles I pour into this cup, it's never going to fill up to the top. So this is a really awesome system for doing things like splashes and people spitting water out, or blood effects, or different you can do kind of drippy, watery effects with this. But the real challenge is the build up of the fluid in the container. So what happens is, if I was to pour particles into, say, a bucket of water or an ocean container or a river or something like that, it just wouldn't be able to simulate. The particles just wouldn't fill up any kind of depth in the river geometry, no matter how many particles you pump into it. So companies in the past have written very complex expressions to get the particles to push off each other at certain radiuses and things like this. But at the end of the day, this is kind of where Maya particles falls over in terms of pouring liquid effects. So it just can't, as you can see, we've pumped a lot of particles in there, and they're all just kind of swirling around in this cup, and they're not actually like creating any kind of depth in the glass. So yeah, that's one thing to notice about Maya particles. So with the with that in mind, there's a lot of awesome things you can do with Maya particles and instancing. Maya particles are really great for debris type effects, or snowflakes, or spray coming off the top of waves, or for all kinds of different geometry-based particle simulations. So if you're doing something that wasn't related to water, that was maybe like tinsel sparkling through the air, or something like check a little piece of paper fluttering down, or glass that's smashed out of a building and it's spinning towards the ground. That's a perfect thing to use Maya particles for. So what we're going to do now is just I'm going to set up a material on these that is more visible. So I'm just going to put some default materials on these glasses so we can see them a bit more clearly. And what we're going to try and do is smooth out these spheres a bit more so that we can get a more liquid look. So you can see what we're trying to do here is just show how this pouring sort of simulation, you could get away with it in a few shots that are really fast or really splashy, but as a main kind of thing, you're not going to get the pouring, filling up kind of liquid look that you're looking for with Maya particles. So these aren't N particles; they're just the standard super fast Maya particles that you may or may not have used before. But there's nothing complicated about this setup. It's just an emitter, two colliding objects, and a random radius on the particle objects themselves. So I'm going to give it a go at doing blobbies, which kind of blends spheres together into a kind of liquidy shape. And you can see that it's kind of made like a bit of a porridgey looking, spew looking, porridgey, gloopy look. And that's kind of cool for slime or dog spit or stuff like that on kind of zombie creatures. But if you're trying to do really stringy, elastic fluids, it doesn't really cut it. What Maya particles are really good for, though, is things like debris, like splintering wood, little pieces of rock that fly up, furniture falling out of buildings, and all these kind of techniques are used in Xeno, which is used at ILM for their effects work. So, even though we can poo-poo it for water simulation, it's really has strengths in other areas. Now we're going to have a look at Maya N fluids and check out how awesome it is at pouring fluids. So when you can see this pouring action happening, you can see that the particles are actually making a dense volume of fluid that's actually holding a kind of internal pressure. So when the fluid is poured into this cup, we can see that it actually creates a swirling mass of kind of particles that kind of have a volume. So it's got volume in the initial cup that the particles are in, and when it pours into the new cup, it holds its own density. This is really different to Maya particles because each particle actually repels other particles, and you can actually do real lifelike water simulations when you use the blobby and mesh geometry types for this particle. So when we go into this particle, we can see that it's using the new N particle solver instead of the old normal dynamics solver for these particles. And what it has is just more options for the particles to self-collide, and keeping in mind that each one of these new options will increase the simulation time for the particles. So you can you have new forces, N cloth works with N particles. They're kind of more like water beads or a bit like marbles, if that makes sense. So it's really important to just keep in these visual kind of things in mind as you're looking at it. So you can see that this simulation is running a lot slower than the Maya particles scene we had earlier. And it's taking like a couple of seconds per frame just to like chug through the maths of the inner particle operations that it's running to get these to work. So if we have a look at a little low res render now, we can see that apart from there being some nice materials on this scene, the water actually looks quite realistic at a small scale. You can actually see that there's a pretty fluid looking substance that's being rendered in this scene, which is really different to the Maya particles scene. So it's a lot easier to recreate this type of water pouring effect with N particles than it is with normal Maya particles. Although you can see here that the simulation time is way slower than Maya particles. So you can definitely use this for pouring liquid simulations, and it's been used previously before Bifrost has come into Maya. But it's important to note that as good as N particles are, competing products like some of the fluid plugins for 3D Max and the awesome fluid tools in Houdini really give N particles a run for their money, because the built-in fluids in Houdini look almost as sophisticated as Bifrost or Scanline's in-house fluid tools. So a lot of feature films that need kind of reviewable, changeable effects work done use Houdini fluids instead of N particles, because they're more detailed and easier to iterate. So we can see here this fluid, this is N particles. It's got a very nice, natural, cohesive, stringy, blobby look to the particles. And we can see here, even when it's poured into the bottom of the glass, it's made like a thin sheet of water as it comes down the bottom of the glass there. So Maya N particles is a great option for basic pouring liquids. Next, we're going to have a look at Bifrost. So although Bifrost isn't going to be able to run on your system, what I'm going to do is I'm not going to go into any menus or change settings or things like that. I'm just going to show you play blasts of a few Bifrost setups so that you can get an understanding of what it does. So Bifrost is just so amazing, I can't even put it into words. It's more the speed of the simulations that really impressed me the most. I mean, I've extensively used RealFlow and other in-house fluid tools, and they're just brutally, excruciatingly slow. And I'm used to slow big scenes, but the fluid simulation software, just to simulate one single frame, can take like 50 minutes or hours. So to see a fluid simulation software like Bifrost, where you can actually scrub the timeline on a large-scale fluid simulation that's like beach size, is just super amazing. Usually other nameless fluid simulation softwares are ideally good for something about the size of an orange juice glass, for doing beautiful, stringy, contoured droplets of water and liquid effects. But Bifrost can easily simulate massive waterfalls or oceans or huge ships breaching out of the water, or submarines breaching out of the water, or any large-scale water effect that can be hundreds of meters wide. So finally, what it's doing is it's solving the problem of having to mix together the ocean trick shader geometry that we saw in the first part of this tutorial, and the super slow blobby particle simulations we saw at the end of the tutorial. So it does everything all together. So it can simulate the big scale, but with the tiny droplet particle detail, which is just so awesome. So what you can do is you can simulate like some really big or really detailed scene, and then mesh the geometry. So instead of using blobby kind of spheres that blend together, you can actually just generate a mesh around where the particles simulate, and you can just see the massive improvement in detail in this fluid scene. So if we go to a certain frame with lots of detail, we can see it's pouring into the glass. It's making this super thin, transparent, elastic water surface with really high edge details into the cup, and it's even spraying up the other side. And each of the particles is actually adhering to other particles and making this very realistic turbulent motion. So not only is it really detailed, but the actual movement and animation of it is extremely scientifically correct for water movement. So it doesn't actually just like create a thin sort of sheet of unbroken water. It actually moves like water, and each particle moves like water. It doesn't just sort of, it's not just like a dodgy fake thing that looks like water at one frame, but it looks weird when it's animated. It actually animates like real water. So this one's actually got a shader on it that's subsurface scattering enabled. That's set up to render like milk. But if you look at this render, I mean, a non-computer graphics person would be hard pressed to spot that as a computer generated image, because computers are really like designed for doing kind of CAD type work, like modeling cars and robots and bridges and things like that. Doing like a glass of milk with such an organic sort of surface like that's animated is really just amazing for a computer to output. And the simulation time is just super quick. The milk pouring simulation is the slowest one of the Bifrost examples, the ocean sized ones being much quicker to simulate, but it's just because of the super high detail of the mesh that's being generated. So I mean, in film production, it's best to mesh at render time in RenderMan or in another renderer that you're using. It's best not to mesh in the actual viewport of the software like what we're doing now, but because this particles can just be meshed when it's sent to the render farm instead of being meshed in a single computer in the scene, because it's just another step that you have to add onto the already time-consuming particle simulation process. So I'll just show you. I've just meshed this in the viewport so you can see where the actual liquid is pouring. So the sphere at the top, the cylinder at the top is the fluid emitter, and this glass shape here is a collider. So that's what the fluid's emitting from. Millions and millions of particles are coming out of that, pouring into that collision object, running the scientific fluid simulation algorithms to create the lifelike movement. And then a separate process is being run to triangulate a geometry around the particle simulation to give it a kind of a solid milk-like surface that can be rendered with the shader. So just one thing to notice is just be careful of the hypershade when you first load up Bifrost, because it can sometimes crash your computer. So we've just left it closed in this little test But next week when we open up our first Bifrost scene, which will be a beach, I'll be able to show you how to create a fresh Bifrost scene from scratch and show you just how amazingly fast and efficient it is at simulating large bodies of water, much faster than N particles and even faster than Maya particle setups with inner particle collision custom expressions. So stay tuned and look forward to launching into Bifrost and some awesome example scenes next week. Bye for now.